Hello friends, this is Praveen and today we are going to learn about the force and pressure. So what exactly is a force? We use many terms such as the force me to do so. So what actually is a force mean in a scientific method? So a force, if we will take a person and take him in a dark room so he cannot see anything, and you are going to push him so he feels something. What is this something? This something is called force. The force is defined as a push or a pull. So the force is technically defined as a force that reacts on a pulling or pushing. So now let's move to the magnitude of the forces. So what is the magnitude of the forces? How much the force you are acting on it. So let's take for example a slippery surface. I will tell you why I am taking the slippery surface. So you place a block here and you started pushing this block in this direction. So you push by 5 newtons. So here Newton is the SI unit of the force. So you are pushing, this would move in with the 5 newtons in this direction. And if in another case, if you are pushing the 5 newton not from this but this direction, the block will move in this direction. This is the scenario only when one force is applied. So this is known as magnitude of forces. But what happens if the two forces are applied or two or more forces is acting on a surface? So let's take a scenario in which two forces in the same direction are putting. So if I have the 5 newtons, one force is acting on 5 newtons and again 5 newtons. So now the block will move faster than it was moving before. How we can calculate it? We know that when we push two forces, it doubles the function. So it would move by 10, that is 5 plus 5, that is. So it would move by the 10 newtons there. For another case, if a is pulling by 150 newtons and here it is pushing by 200 newtons, so the force applied on this block, the total force applied on this block is 200, that is 350 newtons. So this is how you can calculate when the two forces are acting in the same direction. So now let's take the opposite scenario in which both the forces are acting in the opposite direction. So I have a block and it is same place on ice, and now I am pushing a 5 newtons from here and equal person is pushing from opposite. So we will see that they are not moving at all, but if this person slightly increases its force, the block started moving in this direction. So we can assume that the difference now we are taking is we can consider on the left side of this left side of the equation which is applied in this direction as minus forces, that is minus 2, minus 3 and minus that is minus 4, and in this direction is 1, 2, 3 and 4. So let's exceed this. We have now minus 5 force and minus 6 force, and now we have is 5 forces. Now if you are applying 5 forces in this direction, that would be minus 5, and applying 6 direction in this, that is 6. So the difference would be that is 1. So the block is positive 1, that means it is moving in this direction. Here the positive and negative denotes the direction of the force applied. So that is 1 and it is positive, so the block would start moving in this direction. What we have simply done is the subtraction of the two digits. Let's take another scenario for understanding it better. So if I have a block and 200 newtons is applied on here, in the same case here only I applied 50 newtons. So what is in which direction the magnitude of the force is in this direction, because 200 minus 50 it is greater, so the block will move in this direction by 150 newtons. So now let me tell you why I have taken the slippery surface, that is ice, because we observe that there are antiparticles that is known as friction. So friction opposes the thing from moving or coming from moving. So if I have a block and I am applying 5 newtons, and the friction has a maximum of it could apply, I say I could apply only for 5 newtons as much. Let's take a scenario where you are starting from 1. So if you are starting for force 1, the newton that is friction will also apply 1. It would not put its maximum, because we from second of the force we know that everybody has an equal and an opposite reaction. So now if you increase it by 2, in the same way it can until the maximum is 5, so it could put 2 newtons. Then you increase by 3, then it can also 3, and so on until you reach 5. So until 5 newtons the block is at rest, until you apply 5 newtons it is. But what happens if you start moving, putting the 6 newtons of force, it would start moving 1 newton in this direction. So I have taken the smooth surface to reduce the friction, so we do not get miscalculation. So these were the forces applied in the same and opposite direction. So for in higher grades we will learn about what would happen if there is a block and you started pushing from one in this direction and one in this direction. The block neither move in this direction or neither move in this direction, but it moves in both an opposite case, that is in this direction. So it do not move in both these cases. So why this is possible, we will see in the higher grades. So now let's move to the effects of forces. What all can a force do? So there are mainly 5 effects of a force which can do. So first effect is, if I have a body that is a ball, it could make the ball go, that is change its state of motion. Here a state of motion I means, if a body is in rest it would start moving, and if it is moving it would change it and come to its rest. So it would change state of motion. So it would change the state of motion. And second ball, if I have a body that ball is coming, so I can either stop it or I can push it faster. So there are two more, that is change speed and change that would come in if I am stopping it, it would go in the state of motion, or and changes speed, that means I am either slowing it down or either pushing it in a faster. And one more force can do is, if you take a dough and apply a force, it do not move but it changes its shape. So it can change shape. A force can make a body change shape. So it can make the body change shape. And on the fourth, if now I have you ever seen a ball, batsman hitting a ball? What it simply do is changes its direction. So what it can change the direction. So it is change. So it can change the direction. So these are the 4 effects that a force can do. So now let's move to the types of forces. So what types of forces we have? There the two forces are classified mainly in 2 types, which is contact forces, and we have another is non-contact forces. So what is the differentiate between the contact forces and non-contact forces? As the word suggests, the contact forces means they are working when the two surfaces or the two things or two bodies are in a contact, means they are touching each other. But it is not a scenario in the contact force, that is opposite of the non-contact forces are opposite of the contact forces. So in the non-contact forces, they do not require a contact to make the force work. So first let's learn about the contact forces. So there are major two types of the contact forces, which is muscular force and the frictional force. So what is a muscular force? A muscular force is a force that is applied by our hands or by using our muscles. The applying or holding a something, holding this pen is an example of a muscular force. And a frictional force. A frictional force, as we discussed, it is the opposing force, a force which opposes from moving. If there is no contact between them, the force started decreasing. That is, the frictional force started decreasing, or it is not at zero at all. So in air, it has some resistance that we will see. So the friction itself is divided into three types, which mainly two types, which is static forces and kinetic forces. Static, by the word, suggests that it is in rest. As we take the scenario of the block on the ice, I told you why I am taking it, because the friction is applying. So now when the object is in rest, it is harder to pull. That means until you do not move to the maximum the force that the friction provides, you cannot move this block. So this is known as a static forces. A static force is working when a subject and when an object is not moving. For example, this block is not moving, so it is in the static friction. The static friction is applied on this block. And the another type of the friction is known as kinetic friction. A kinetic friction, that means a body is moving. So let's take a body is moving, and this friction is stopping from moving, or it is decelerating for the speed of the block. So this is known as a kinetic friction. And kinetic frictions are then divided into two types, which are rolling friction and that is sliding friction. So what you can do is that you take a stack of books, so here I have a stack of books, and you plane an inclined surface in that direction. So now what to take, you take a pen or cylinder and roll it. And another you can do is to take a block, or a copy, you can take a book also and slide it. You will observe that you will find the rolling of the friction rolling of the block much easier than the sliding. So the rolling or the cylinder which is rolling down, in this case, rolling friction is applied. The rolling friction is a friction which is stop the pulling of the rotating body, and sliding when the body is sliding itself. So if I have to describe what would be the amount of the force required by these three frictions, that is static friction, rolling friction and sliding friction, so I can on the same surface. So if I have a same surface, that otherwise the rougher the surface, rougher the friction. So if in this case rolling friction is the least, then we have is the sliding friction, and then we have is the static friction. So it is rolling friction, then is sliding friction, then we have is static friction. So this is the magnitude of the forces which is applied. So harder, you have to push harder to the static friction compared to the rolling frictions. And for competitive approach, the static friction is also known as the limiting friction. So now let's move to the advantages and the disadvantages of the friction. So what are the advantages and disadvantages of friction? The friction first help us to grab things. So if I am holding this pen, this is because of friction, otherwise it would slip from my hand. Holding smartphones, playing different games with just like bat, it do not moves away from your slips. This is because of the friction. We use grip that provides a better grip to hold the bat. Now we have disadvantages of friction. Because of the disadvantages of friction, your boots do not last more. But you can say, but it is also a good thing that it helps us to walk. So we can see the friction as a necessary evil. So now let's move to the how to increase and decrease friction. Because when we want either the higher friction is bad and the lower friction is bad. So how we can increase the friction according to our needs? So first, for we know that that is sliding friction is much more easier than the rolling friction. So what scientists do, they have created a ball bearing. So what do it have is they have the three circular things in which balls are put. So here are the small metallic balls. So what they do, instead of this stage sliding with this stage, they roll against each other. This provides a less friction, and this is the case in where you can reduce friction. Another case is the lubricant. You put powder when a carom that a carom surface becomes rough. This is help because the surfaces get bumpy, and when something got it could stuck between this. So what you do is put a lubricant so it evens the surface, and you can so it provides the more easy movement compared to the friction. The another this is ways to increase friction, but how you can decrease friction? You can decrease friction by using grips. That's why you have a grip on your shoes so that it could easily grab the ground and you enables you to walk. So these were the how to increase and decrease friction. So now let's move to the non-contact forces. So what are the non-contact forces? So, non-contact forces are of three types: gravitational force, electrostatic force, and the magnetic forces. So first let's learn about the gravitational force. So what is the gravitational force? A gravitational force is when the two bodies, when they're not in contact, they would attract each other. That means everything in this world attracts each other thing. So if I have this pen, the pen is attracted by me and I am also attracted by the pen, but the friction is much more higher, let the pen come to me. But the gravitation force, that means the earth is much more in mass compared to me, so the pen is moving in downwards, for example, downward direction as soon I leave it. This is the case why if you this is the earth and this is the moon, it is moving in a continuous circle. Why do the moon do not fly randomly? This is because of the gravitation force. The moon also pulls the earth and the earth also pulls the sun. That's why it maintains its velocity and go round the earth. In the same way, if we have the sun, the earth moves around the sun. So this is how the gravitation force is important. And in fact, our weight also depends upon the gravitation. The technical definition of the weight, that is equals to mass multiplied by the gravitation is equals to weight. So the higher the gravitation, the more the weight you have. You will have more weight on Jupiter compared to the Earth. Earth, if you have the weight on that is the 60 kgs on the Earth, that is much more gravitation than compared to the moon. So also on the moon you will have only 1/6, that is only 10 kgs. So you would jump more higher than compared to the Earth. That is six times more higher on the moon. So this is the gravitation force. It do not require a contact between each other. And now let's move to the electrostatic forces. We have seen about electricity or learned about the electricity. So what is the electrostatic means? Electro means electricity and static, as we discussed, it means rest. So this is when the two that is the electric charges are in rest. So have you ever tried to rub your balloon on your skin and then try to raise the paper clips? That is because of electrostatic charge. So what happens when the two surfaces are rubbed against each other? These all surfaces are made up of atoms. So if you have take a, how does the atom looks like? So here we have is a nucleus which is made up of the protons and electrons, and here we have is shells which is electrons present here. Electrons are present here. So what happens if the electron by rubbing changes or it loses here? you will know that in atom the number of that is protons is equals to the number of electrons. That makes that is atom a neutral charge. But when you have more proton charges, that means positive charges, the atom becomes positive. But and less the negative charges, the more the negative charges, the atom becomes negative. So due to the rubbing or by bringing another charged body, what happens? This electron shifted its direction from one surface to the another. So what they creates at one object, it creates a positive charge, and another surface it creates a negative charge. So we know that negative and positive are attracted, so these two pieces would attract, and if you will bring another body which is rubbed with that, and you bring a positive charge body near it, it would repel. In the same case, the like charges repel and the unlike charges attract. If you take in the negative case, the negative charges also would repel each other. But a negative or a positive or a negative would attract each other out. So this is the electrostatic forces. The reasons why the lightning strike the earth is because of the electrostatic forces. So now let's learn about the magnetic forces. So what is the magnetic force? A magnetic force is works when the two surfaces, if you take two magnets, that is north and south, this property states between the two magnets. So if we have a north pole and north pole, we learn that north and north repel each other, that is like charges repel each other and unlike charges attract each other. So in the same way, unlike poles attract each other, and the same poles attract, that is same poles repel each other. So north and north would repel, south and south would repel, but north and south or south and north would attract each other out. So this could be so I have told you the same concept in the, that is the electrostatic forces and magnetic forces, but how we can prove that? So you can prove that if you have you have to take three magnets, that you can take three magnets, and let's take this north, and let's take this north, and you don't know a magnet which is coming to you. So if it is attracting by it, let's with our hypothesis we can this is north, because north and north attract each other, but actually it is south, and in another case it will be actually south, but we are taking it as north. But when we will so when these both repel, now it is north, and now these three start, we know this would be imaginary south and this would be imaginary north. So now these both started attracting each other, but according to our hypothesis, this was north and this was south, they should repel each other. So this is not our case. So now we can see why the north and north repel each other and south repel, but north and south attract each other. So this was the first topic. Let's move to the pressure. So what is the pressure? So if something told you I am being pressurized, that means in the technical definition, it means that a force which is applied, that it is defined as the force per unit area. So it is force per unit area, that is. So SI unit of the force is Newton, and the area is meter per square, that is meter square. So the that is the pressure. SI unit of the pressure would be Newton, that is, and that is -2. So this is the, in this in the science we have its name as Pascal. So if to convert it to Pascal, you have to take the units as a meter per, that is meter square, and the newtons. So let's take the few examples to how to solve these questions. If 800 newtons of forces is applied on the 2 meter square surface, so what is the pressure? The pressure is, now you can simply divide, that is 400 newtons meter square. So this is how can you, and we know that this is referred to as Pascal, so you can put the PA. So now let's see the variation. What are the different variation that for the pressure follows? So if you will take force and area is equals to pressure. So we have pressure. So when the force is increased, what would happen is the pressure also increase, because on the same amount of area we are applying a higher pressure. So the force also increase in the scenario. Oh, but what happens if our force is decreased or the pressure also decreased, because now the pressure, the force applied per unit area is also lesser, so we apply a less pressure. But it would be the opposite scenario. When the area is increased, the pressure would decrease, because now smaller the force is same but it is spread on a larger area. And if the in the same case, if the area is decreased, the pressure would increase. We can see that the pressure is that is inversely proportional to 1 by that is area, that is area, and direct is proportional is to the that is force. So this is how the variation of the force pressure works. So now let's learn about the liquid pressure. So what is the first let's learn about the fluid pressure. The fluid, both as air and gas, is known as the fluids. We know, and because they are flowing. So now fluid pressure is applied by the both either air or the water. So we can describe differentiate between in the liquids and in air. So first let's learn about in liquids. So in liquids, when if you will take a container filled with water and you put a hole at let's you put different holes on the beaker, so that now we can see where the pressure is more, on the topmost or on these. But you will see that on the topmost it comes the water comes here, and in the second, in the third, in the fourth, and in the fifth. But higher you go down, the pressure started increasing, because you can take this as a layers of water. Only the top layer have to take only its weight, so it has a less pressure, because we know that the weight is defined as the gravity, and the weight is the force, and it is defined as the gravitation multiplied by the mass. So it has a mass. Now the second layer have to carry its weight also, and the top layer's weight also, so its pressure increases. So we can conclude as we move in the depth, the pressure started increasing. So as we move in the depth, the pressure started increasing in liquids. And one more day, you can ask the question is we are taking it in the that is the horizontal direction. Now can we take it to a vertical direction? So if you will put a hole in the equal depth on the two sides of the beaker, you will notice that a same length is covered. That means the same pressure. So the water here we can conclude two different things with water, that the water applies the pressure in all directions, and one more thing, that the pressure in with the same depth is the equal. So these are the pressure that is in liquids. So what are we see what is their properties. Now let's move to the pressure in air. So if you will take we know that air, let's this is the earth, and we have an atmosphere, and we know that to a definition of air is a matter, and matter has a weight, and it has molecules. So it has weight. Now the air has a minute level of weight, but it has weight, but it is extending in so much kilometers that the forces acting you upon you is 2, that is tons. That means you are holding a small car on your head while doing every other work. So this pressure which is applying on you is known as 1 atm. That is the air, that is measured the unit of the air pressure. So this is the air pressure. So what are the properties of the air pressure? If you will take a balloon filled with air. So if you have a balloon filled with air, you will see that it applies the pressure in all the directions. If it is only applying the pressure in this down direction, then the downward balloon would bulge, but in the top balloon it would not bulge. So this is how the friction of the fluid works. And the upper you get, the friction, that pressure is decreased, because now you have to hold only the weight of the air which is only above you. So you have to weight only a small. The pressure is decreased. So now let's move to the different applications of the pressure. So what are the different applications of the pressure? First, as needles of the injections are not flat. Why they are not flat? Because to increase this contact point, that means they are increasing the pressure. So it could easily pierce through our skin, and they could give you the required dose. So they are not exactly flat, but they are trying to decrease the contact area as much as possible. In the same scenario as a hammer and a nail. If you take a nail, that is a sharp nail, it would easily go into the wall. But if you take a blunt nail, that would bend due to the it is not straight. So it would bend because the it has not much force that only the wall could resist. So this is an example of hammer, and you have noticed that the dams at the bottom have much more breadth than compared to the top, because this applies the same, that at the top bottom the friction started increasing. So let's summarize what we have learned today. So we have learned today about what is the force. Then we learn about how to calculate the magnitudes of the forces, effects of the forces, what are the different effects of the four effects of the forces, types of the forces, that is contact and non-contact forces. The contact forces are divided into muscular and frictional forces, and the frictional force, which is further divided into static and kinetic force. The kinetic force is further divided into rolling and sliding frictions. Then we learn about the advantages and disadvantages of the friction, and then we learn about how we can decrease and increase the friction according to our needs. Then we learn about the non-contact forces. These are gravitation, electrostatic, and magnetic. Then we started learning about pressure. That is how pressure varies, fluid pressure in liquids and its properties, in air and its properties. And then at the last, we learned about the applications of the pressure. So friends, I hope that the force and pressure is clear to you, and at last, thanks for watching.